Okay, do you guys want lights off for this?
Sure.
Okay. All right, so let's go over this. We're going to go through and calculate all this good stuff here. Okay, so we have, there we go. Okay, so write cosine in terms of tangent of x. Now, we have a couple of different things that we have here. So secant is related, but it doesn't really matter for this. So cosine in terms of tan x. So I'm going to show you guys a couple tricks to go along with this. Now, the Pythagorean identity, we know, because we've been doing this so long, it's going to be x squared plus y squared equals 1, right? Yes, right? Okay. Yes?
Yes.
Okay. So, now, since we have that, we're trying to get one of those by itself. Okay, so I have this identity right here. Okay, this is actually this moved around. Okay, so I'm going to divide everything. I'm going to divide everything by x squared. Because we know that x represents my cosine, y represents my sine, so I'm going to divide everything by x squared. And this is what I was talking about the other day when we were talking about making all of our identities. So we're going to do this and make our own identities, right? Now, by dividing each one of these terms by x squared divided by x squared gives me 1, right? So 1 plus y squared over x squared equals 1 over x squared. Now, using my x, y's, and r's, okay, or, now, in this case, my r is going to be 1. Okay, just like on my unit circle, my radius of my circle is 1. So my r on this case is going to be 1. So now, y over x gives me tangent, right? Y over x is tangent. So y squared over x squared is tangent squared. So 1 over x is secant, right? 1 over x is secant. So 1 over x squared is secant squared. Okay, so this is going to be a new way of doing this. So 1 plus tangent squared equals secant squared. So I just made this from this. Okay? So now I'm going to go through and actually manipulate this whole thing, but I'm going to use this instead. Okay? So I'm going to use this right here. So we know that this is the same as writing what? 1 over cosine squared. So this is the same as writing 1 over cosine squared. So this is where I got that from. So if this is the same as saying 1 over cosine squared, I'm going to write that. 1 plus tangent squared x equals 1 over cosine squared x. Do you agree? Now, I have this fraction down here. Okay, this fraction, the cosine, it's on the bottom. I don't like fractions. I want to get rid of it. So, since I have an equal sign here, what would I do to get rid of my fraction? Multiply both sides of the equation by cosine squared. So I'm going to do that. So I'm just going to put cosine squared instead of the x because I don't want to mistake it from what I have up here. So cosine squared. So I'm going to multiply both sides by cosine squared. So now I have times 1 plus tan squared equals 1, right? Okay. So by doing that, I've now been able to just get the 1 over here by itself. The cosine is now on this side. We're trying to isolate it to get the cosine by itself. So what would I do to get all this gone, the 1 plus tangent squared gone? Divide both sides, right? Divide both sides. I'm going to divide both sides by 1 plus tangent squared. Right there. So now those cancel, so I get cosine squared is equal to 1 over 1 plus tangent. Where's my eraser? There it is. Okay, I'm almost there. Because I'm trying to get cosine by itself equals something of tangent.
Does the ones cancel out?
No, it's not going to cancel out. The only way that it would cancel out, if there was like a 1 in front of all this. Because this is, right here, 1 over all of this. I can't break up this. I could do that if I had it in the numerator. So if it was a reciprocal, I could break up the numerator into parts, but I can't do that like that with the denominator. Okay? So, how do I undo my cosine square to get it just cosine? Square root. So I would end up with cosine of x, this is going to be my final answer, is equal to plus or minus the square root of 1 over 1 plus tangent squared x. So like I said, this is different, it's manipulation, and it's all algebra.
Is the R always going to be 1?
R is 1. Whenever we're dealing with identities,
Okay.
R is 1. Because my unit circle, when you look at the unit circle again, the radius is 1 of the whole thing. So that's where I'm making all my identities from.
Okay, so just all identities are 1.
Yes, all identities, R is 1. Alright, are we okay there? Okay. So let's go ahead, take a look at the next one. Did they write the same thing? That was example 2. Hoping they actually wrote it similar. No. They broke it up differently. It still comes out to be the same. They didn't like the square root in the bottom, but yeah, it's still fine. It's equivalent. All right. So now write 1 plus cotangent squared over 1 minus secant squared in terms of sine and cosine. This is where the algebra comes into play. Now, in the upper right-hand corner of your unit circle, it has what each one represents, your x's and your y's. So I'm going to write this, and I'm going to use it just pure algebra terms. Pure algebra terms here. So if I write this, it's going to be 1 plus, now cotangent is what over what? X over y. But if it's cotangent squared, it's x squared over, very good. So x squared over y squared, all that's going to be over 1 minus, now, right here, cosecant squared. Cosecant is usually 1 over y. Okay, 1 over y. But if it's cosecant squared, it's 1 over y squared. So it's 1 over y squared. Okay. So now this is one way of writing it in terms of sine and cosine. Okay? Then simplify the expression so that no quotients appear. That means no what? Fractions, right? No fractions. So we're going to get rid of fractions on this. Now, this is algebra right here. Okay? So right here, what is the common denominator for both top and bottom? Y squared. That's a y squared, right? And this one also has a y squared. So I'm going to do common denominator both top and bottom. So I'm going to multiply both by y squared. So I'm going to distribute the y squared into there. 1 times y squared gives me? Y squared. Now, right here, what's going to happen? The y squareds cancel, don't they? So I'm left with just x squared. So that's plus x squared. over. As I distribute here, I get y squared minus 1. There we go. So I've cleaned it up a lot just by doing that. Okay, now I'm reaching to my bag of candy for this one. Who could tell me what is the top? What is the top part of that fraction? It's y squared plus x squared. Very good, but it equals something else.
Pythagorean theorem.
Huh? Equals 1. Very good. There you go. Because my Pythagorean theorem is x squared plus y squared equals 1. Yes, it is Pythagorean theorem, right? X squared plus y squared equals 1. And isn't this, we're using identities. And so I could replace all this on top with just 1. So that's now going to turn into 1 over y squared minus 1. Right? Yes? Okay, so now I have now got rid of a lot of it. Okay, so now the next part of this. I don't want the piece in the bottom. I am going to multiply by 1, but what's my 1 going to look like? It's going to be y squared what? Y squared.
Like
So,
the whole bottom.
the whole bottom? So you're saying that I'm going to have 1 over y squared minus 1 times what? Y squared minus 1 over y squared minus 1. But what is that going to give me? It's I'm still not going to fix the bottom piece. You're almost there. You're like 90% there on the right track on that one. Take out the bottom part. Okay. I kind of can. I could do that, right? So if I go with, instead of doing that, let's go back to that Pythagorean identity of x squared plus y squared equals 1. Can I do some manipulating here? I can. Okay, because I'm trying to get this piece right here. Can I make this piece from this? Yes, what would I do? So I would subtract the 1, right? So if I subtract 1 from both sides, I get x squared plus y squared minus 1 equals 0.
You divide by x squared.
Not divide by x squared. I would subtract the x squared, right? I would subtract the x squared to get that on the other side. So let's minus x squared. So y squared minus 1 is equal to negative x squared. So now I could actually take care of that, right? So now, since I've used the Pythagorean identity again for this one, I am now, this is now just going to be 1 over negative x squared.
And the negative will go in the middle, right?
Okay, the negative will go in the middle. Okay, so simplify that no quotients appear. Now, can I rewrite this as it's no longer going to be a fraction? What is that going to become? What is 1 over x squared? That secant, right? It's secant. X is the secant, right? So the negative out front means that this is going to become a... So this comes negative secant squared x. So we started with this. Use terms of sine and cosine. And my last final step that I did was no quotient. Simplify the expression so that no quotients appear. so that there's no fractions in this. So now I simplified it down all the way here, and then I was able to simplify it down to a secant by itself. There's no longer any fractions here. Is everyone still awake? I think Abraham just fell asleep. He's kind of sleeping there. Okay, all right.
I've never been so confused.
I'm just confused.
Okay. Hey, seriously, this is, like I said, I told you guys, I warned you yesterday. Brand new math for most of you. Okay?
Fractions are never my friends in there.
Okay, yes. Fractions are friends, not food.
There's going to be a video on this, right?
Yes, I'm
Okay,
making
so-
one right now. You can hear me in the video talking about the video during the video while we're asking about the video.
Wait, so it's recording right now?
Yes.
Oh.
Okay. All right. Let's try another one. Let's try another one. All right. So
Wait, we
They
don't.
don't have another one.
Yeah, we don't have those.
you don't have another one?
No.
Oh,
That was
okay.
the last of our thing.
Good. Let's try another one. Give me a problem for one of your homework.
Oh, wait.
All of them.
Yeah, you should have showed up on time.
We don't even do 14 through 20.
I know, right?
25 through 31 on.
I used it for another class. It would give me
Oh,
Oh,
okay,
it's
no
right
problem.
here.
Okay, 53 is one of your problems. So same as the last problem. So 53 says cotangent theta sine theta. The last one I gave you on the notes is probably one of the more complicated ones. You're going to see a lot that are just like this. Now, okay, translate this into algebra first. Translate this into algebra. Cotangent is what over what? X over y. So I'm going to write this as x over y times. What is sine? Y over r. But what is my r?
1.
So it's going to be times y over 1. Now, translating this into algebra, does it look really easy now?
Yeah.
What's going to happen here? Y is going to cancel, right?
That's
Which is x over 1.
So y is going to cancel here.
Which is just x.
X over 1, which is just x. So my answer is,
X.
translate it back to trig,
Oh,
cosine theta.
So the answer that he was right is just cosine.
Yep, with your work.
why would
The
you
ones we
even
did on the
look
board
at
were a lot more
this?
complicated than ones that are in our homework.
Okay, so now, okay, I heard like 3 people at once. Anna, go ahead.
So the questions that you get in the notes are harder than the ones in the
I try to because I don't want to be that math teacher that's going to give you something really easy, but then when it comes down to the test, you're like, what is the airspeed velocity of a maiden swallow? And you're like, what the hell? You know, and you're like an African or a European swallow, and you're like, what the hell? Yes, Monty Python.
Yeah.
There we go. All right.
She does that.
Anyway, okay. So let me grab another one. I'll even do another one of your problems.
So generous. 55.
55. Do something harder. Seriously.
57.
65.
What number?
No. You know what? 62.
When did that even one? Wait.
It's hard. You want it harder.
I know, but that's not one of our homework.
Do one of our problems for us.
Whatever. If you want 61.
65.
Because
61. What number are we doing?
I don't know. So I like these problems. I really do. Because if you translate it into algebra, you could see it. Everything actually like comes out, and you're like, wow, okay, I should have paid more attention to algebra. Okay, so let's start with this one right here. Translate it.
Y over 1.
Y over 1. So I'm going to have y over 1 times cosecant. 1 over y, right? Minus sine, which is
Y over 1.
and this is one of the harder ones.
What? This is easy.
Bruh, seriously.
So you can cancel out the ones in the parentheses, but not the outside, right?
It's just why.
Yeah, so
Okay.
It's just
So yeah.
sine.
So it's just gonna almost.
Wait,
Almost.
because
Almost.
oh, is it negative sign?
Almost. Okay. Let's distribute. Okay. I am losing some people because yes. Hold on. Ah. Okay. All right. So for this one right here, I have to distribute. When I distribute here, y times 1 is y. 1 times y is y. Y over y gives me.
Why?
Y squared.
Why? What?
What?
It's just going to be 1, right? Y divided by y gives me 1.
Okay.
So right here it's y over y. Those cancel out. That's kind of like 5 divided by 5. It gives me 1. Okay? X divided by x is 1. Okay? Now, as I distribute this way, minus y times y is over 1 times 1.
1.
The y is cancelled.
1 minus y squared. Yes, this is the hardest part of this one right here.
So you can equal it to x.
Yes.
That would be your x.
Yes. So, let's take a look at the Pythagorean identity real quick. Okay, Pythagorean identity again.
X squared.
Equals 1. Okay, whenever I have something like this, can you simplify it using Pythagorean identity?
Yeah.
Can I move this around to match this?
Yes.
Okay, so it's going to be what? What would I do to get this?
Negative
It's just
1.
Subtract y squared. So x squared is equal to 1 minus y squared, right? So
Oh.
I move this around to try and match this. If you were in a different class, you would have to memorize all your identities. But this is not that class. I show you how to do it, and you try to match it. You make it work. Yes?
So it's just gonna be x squared.
Yeah.
Never mind. You did a different way to me.
Okay.
Never mind.
So now I am replacing this with x squared. So my answer comes out to be cosine squared. Am I using theta on this one? Yeah, theta. Now, you feel excited about this?
Why does it
No, it is theta because back in my original problem, it was sine and it was using theta as my angle. Okay. All right. Okay. Don't forget, like and subscribe.